But yes, Vlăduț is here to give us his first DConf talk, so take it away.
Thank you. So, greetings everybody. My name is Vlăduț, and I'm going to talk about this scanner migrating from libdparse to DMD-as-a-library. Now, before I begin, let me tell you a few words about me. I graduated just this summer from University Polytechnic of Bucharest. I completed a 4-year bachelor's program in computer science and engineering. I've been with Adobe for over 2 years now. I've met some awesome people here, and my main programming experience lies in the JVM world, so Java and Kotlin, but I also did plenty of other interesting stuff, such as operational work. Now, I got into through this project. To be more specific, in my 3rd year of university, I had to take an introductory course into operating systems and went to Răzvan Nițu's laboratory. And there he talked a lot about D, about how it is such a cool language and that he has some interesting projects to work on. And naturally, I was intrigued, and that's how I got here. With that out of the way, let's begin. So what exactly is this DScanner? A static code analysis tool. Basically, it reads your code and gives you various insights about it. To be more specific, it's used to detect several bad practices or perform some style checks. Overall, I'd say it's used to detect questionable code. Now, this scanner is pretty feature-rich, offers over 50 code checks, and it's a pretty important project for the community. To give you an example, it is actively used in the Phobos repository, and the Phobos contributors take the warnings that this scanner generates very seriously. So let's take a quick look at this scanner's architecture. It actually uses a third-party parser called libdparse that implements 2 compilation phases, the lexical and the syntactic analysis steps. And the way it works, it reads your code, it passes that code through those compilation phases, and it emits an AST, or abstract syntax tree. Now, this AST is passed down to the static analysis step, and the way the checks are implemented is using the visitor design pattern, and the way that works is the visitors traverse the AST, stop on the target node, and perform some checks there to emit some warnings about your code. Now, the objective for this project is to actually remove this libdparse dependency and replace it with DMD-as-a-library. Since we're changing our compiler library, we can expect that those compilation phases will change a bit. We'll also gain access to a new one, the semantic analysis step. Obviously, since those compilation phases change, we can expect a different AST. And since we want to keep the same behavior going on in this scanner, we're going to have to go through each check and migrate it so that it can actually detect the same warnings on this different AST. Now, why exactly should we use DMD-as-a-library? The most obvious reason is that it's going to be easier to tackle compiler updates. To give you an example, let's say we reach the point where we implement deep 9999 in the compiler, but before we can start using it in our project, we're first going to have to replicate those changes in this libdparse dependency so that we can go ahead in this scanner or any other project for that matter and upgrade the library version so that we can start using it. Now, if we actually use DMD-as-a-library, we can bypass this whole intermediate step of having to keep the third-party dependency in sync. Another important benefit that we get from using DMD-as-a-library is that we gain access to its semantic analysis step. Semantic analysis is a fairly difficult compilation phase to implement. You need a lot of information about the code. And while you can go ahead and implement some parts of it so that you can use in your project, still going to be fairly limited compared to what DMD-as-a-library has to offer. And since it's already implemented, why not use it? Now, this will allow us, at least in this scanner, to implement more comprehensible checks. And to give you an example, think of string mixins. Without semantic analysis, all you can see is a string expression, but with semantic analysis, we can actually extract more meaning out of that expression. There's actually an additional bonus for DMD-as-a-library. DMD-as-a-library has only been out for a few years now, so still it's in early stages. The compiler interface still changes. Sometimes those changes are breaking changes that break our code, but by using it in a project that's actually used, we can get some real data about how this interface should look like. Now, let's take a look at what has been done for this project. Before me, Lucian Dănescu has also worked on the same project. He also held a talk about 2 years ago at DConf, where he talked about integrating DMD-as-a-library in this scanner, and he focused more on showing what DMD-as-a-library has to offer and how several checks work. If you haven't seen the talk, I recommend that you do. Now, I started working on this project in the fall of 2023, so about 1 year ago. And when I started, 24 out of 54 checks were already migrated to DMD-as-a-library. A few other checks were almost finished, so there were several pull requests open that I had to merge. And the code infrastructure for using DMD-as-a-library was already there. And by that, I mean the code necessary to parse modules using DMD and run the DMD checks. Now, if you take a look at the work required, I can say that I started working on this project when it was about halfway done, so a fair 50%. What I've done is I have actually finished migrating those checks to DMD-as-a-library, and I also did some other boring stuff, maintenance work such as upgrading dependencies or improving a unit test here and there. If we go back to the work required chart, I'd say I've done about 49% of what was left to actually integrate this in the upstream, but there's still about 1% left that I'm gonna talk about later in the talk. I actually went ahead and benchmarked the changes that we made during our migration on my personal laptop by running this scanner on the Phobos source code. Actually, I've noticed an improvement in around 15%, so maybe 2 seconds by using the library as opposed to libdparse. Now, whilst Lucian's talk was more focused about showing the details of DMD-as-a-library and showing how several checks work, what I'm going to show you instead is what our workflow looked like, several challenges we have encountered when dealing with DMD-as-a-library, and the efforts necessary for keeping up with the upstream. So for our workflow, we followed a pretty standard model of open source collaboration. We have forked the official repository, we made our own main branch, and we also had to update our build files in order to include DMD. For the migration process, we had 2 main concerns to keep in mind. First is that whatever checks we migrate, they still work as expected, so we don't break anything. And at the same time, the changes that we are bringing in do not affect other areas of this scanner. So for that reason, let's take a quick look at the flow for analyzing code in this scanner. Starts from the code, the module is parsed, then the specific checks are selected based on what the user configuration looks like, and then those checks are run. What we did was actually we cloned this exact flow, but made it work with DMD instead. And we kept the same, both flows running in our program, so whenever we migrated the check, we simply moved it from the libdparse flow to the DMD-as-a-library flow. Now, for our testing pipeline, we have used GitHub Actions, and we have decided to do whatever the upstream scanner is doing so that we have an easier time integrating our changes with the upstream when the time comes. And for that, we had to make sure our application could actually compile. We did that on a combination of platforms, compilers, and build systems. So think of Windows, macOS, Ubuntu, DMD, LDC, GDC, Makefile, Dub. After that, we made sure that our unit tests pass. And we finished off the pipeline with integration tests. The integration tests are actually implemented by running this scanner on the whole Phobos repository. Since I said in the beginning that these scanner warnings are taken seriously by Phobos contributors, we should expect that a clean scanner run should not generate any additional errors on the Phobos repository. And this is how a successful pipeline looks like. Now let's take a look at a few challenges I've encountered when dealing with DMD-as-a-library. The first one is that it's not always intuitive when you have to go and read the code, and since you don't have documentation, you're going to have to dig through the code a lot. So to give you an example, I had to look for the function parameters, and naturally, I thought I can find the parameters in the function declaration AST node. And there is actually a class field here that says parameters, and the DDoc says array of var declaration for parameters. However, when using it in my code, I actually find out that this is null, and it only gets initialized after semantic analysis. So I started digging back in the code, but it was starting to take quite some time, so I asked Răzvan for help. And we looked in the parent class, which has a type field. And for our functions, this is actually a type function. So not only it contains the return type of the function, but it also has the parameter list. Now, there's been another issue when dealing with DMD-as-a-library strings and the D strings. Naturally, as a D applications developer, I just want to use D strings and not worry about anything else. So immutable char arrays. However, for example, if you need to get the string representation of an identifier to see, for example, a variable name, there's this convenient toString method that returns a const char array. And if you want to use it in your code, you're going to have to perform a cast. Another issue I found is that there's a lot of external C++ in the DMD-as-a-library classes. So if you want to use those classes in your code, you're going to have to extern C++ as well. But if you want to use D strings in your function parameters, you're going to have to extern D. This is not necessarily a big issue, but it can pollute your code if you have a combination of the two, where, for example, you have a check where you have to work much more with strings. There have been a few checks that we have deleted as a consequence of using DMD-as-a-library. The float operator check and the comma expression check are actually two checks that warn against the usage of deprecated language features, but those features have been deprecated for quite some years now, so DMD-as-a-library will not consider this valid code. It will actually throw a compilation error, and that compilation error would break our application when we would try to parse the module, so we have to delete them. Another check we have deleted is the state attribute check. It looks for two of the attributes on functions, but again, this is now a compiler error. The code will not compile with two of the same attribute, and this will also break our code, so we had to remove it. There's an additional check that we removed, the if statement check. This actually warns against redundant if conditions in nested if statements, but it was actually disabled in 2015 because it was generating too many false positives and hasn't been touched ever since. And in order to clean up the code base a bit, we have decided to remove it. Now let's take a look at the efforts that were required to keep up with the upstream. Rebasing. So we monitored the changes that were going on in the upstream project, and we were noticing many of them happening, so we thought it would be a better idea to rebase at the end of the migration so that we don't have to work that much. However, we reached a point where our testing pipeline would fail due to some conflicts with dependency versions and compiler versions, and the upstream repository did not have those type of issues, so we thought that we can rebase the changes that were made in the upstream repository so we can fix our pipeline. And on January 29th, a rebase was started by Eddie. If you're wondering why it looks closed, it's because he used this pull request only to test the changes he was bringing. And during this time, I was kind of stuck with merging my checks. So I was chatting with Răzvan, and I was asking, hey, how long is this rebase going to take? And Răzvan was like, don't worry about it, just a few days. After a few days, I'd ask again, how long will this rebase take? And he'll just say, just a couple of days, don't worry about it. Eventually, the rebase was finished by this commit on 19th of February, so about 3 weeks. Now, the reason this rebase took so long is because besides other small changes such as bug fixes or test improvements or small features, some refactorization was performed in this scanner that changed the constructor arguments for all of the checks. So Răzvan and Eddie actually had to go through each file and make sure that they only bring the changes that we are interested in and not the constructor changes. Another issue when trying to keep up with the upstream we have encountered is that DMD-as-a-library updates a lot, and sometimes those updates break our code. There are a few checks in this scanner that look for redundant parentheses, and conveniently enough, there's a parents field in the expression AST node that tells us whether or not the expression is parenthesized, but it got removed from the node by Walter. The purpose was that it wasn't necessarily needed, and in order to clean up the code, it was removed. However, this not only caused issues in our code, but also caused some other issues in a bug regression regarding string concatenation, and Theodore reverted this change and we could fix our code then. There's also an issue regarding our integration pipeline, so we had to ensure our pipeline works in order to be as close as possible to the upstream. In order to use DMD, you're first going to have to generate some configuration files, so the sysconf dir and a version file, and when you install the DMD compiler, those automatically get generated for you. But if you want to use it in your code, you're going to have to run a small config file in order to generate those. With LDC DMD, you can actually run those files on the fly without worrying about an executable. But with GDC, you cannot do that. So we had to fix our make file in order to create this special case for the GDC compiler so that we generate the binary, execute it, and then remove it. Let's take a look at the conclusions for this project. As for the missing 1% I was talking about in the beginning and future work, I got to fix autofix. Autofix is a feature that has been added in this scanner that allows it to automatically fix your code in place so that you don't have to manually go there and fix it yourself. The no-lint user attribute, this is actually used for only a few checks, so it shouldn't take that long. It's actually used to disable linting at local scopes. And there's a new project idea that we use semantic analysis in this scanner and implement some cooler checks. Now, as for proper conclusions, DMD-as-a-library is actually usable, and the proof is this project. Obviously, it's not in a perfect state, but you can go ahead and build awesome tools with it. DMD-as-a-library could benefit a lot from public and proper documentation. At the end of the day, yeah, you can still go and search through the code and find your answers there, but it's much faster and much easier to open a public documentation page and find your answers there. And once we integrate those changes with the upstream, we invite you to go test them out, report any bugs you find, and maybe you can even come up with new ideas or just tell us whether you like it or not. As for some personal thoughts, I believe compilers are fascinating. It's awesome to see the journey your code takes from text to a bunch of zeros and one. And I think it's even more fascinating that you can hijack those compilation phases to build tools that are only designed to improve the life of developers. I believe D is a cool language, primarily because it's not that opinionated, so you can shape your code purely on your need. And rebasing is not fun at all. Now, I'd like to end this presentation with an open question, whether or not is it a good idea to share the same code base with the compiler, because from the perspective of a library user, you just want to get the most out of that library, and at the same time, get long-term stability, so little updates or updates that don't break your code. But if we look at it from the perspective of a library and compiler developer, you don't want to have to maintain many features that your users come up with. And with long-term stability, you lose your freedom to freely refactor the code as you see fit in order to improve the compiler code base. And if we pair this up with the additions coming up, I can only imagine the amount of work a compiler developer has to go through in order to keep track of all of those issues. So that would be it. Any questions?
What are some of the differences between dscanner and LDC Lint?
I'm not sure what LDC Lint is. I haven't checked it out, so I cannot say.
Okay.
I can answer about the LDC Lint part. First, the biggest thing is that dscanner is usable in production. LDC Lint is not. And another thing is that the dscanner runs the whole semantic phase again, and the LDC Lint, the main objective is to run as part of the compilation phase. So you compile and then run the linter after compile.
So did you mention a performance benchmark where you compare how long it takes for the decompiler to do a syntax check opposite to, or a syntax semantic check opposite to what dscanner takes? Because you only compared against libdparse. I was just curious, what is the overhead of running dscanner inside the compiler? It's by default. Is that something you measured?
I don't think so.
Yeah.
So maybe I can think about it, but I cannot even come up with an estimate. Maybe just a guess.
Okay. So one other question. So I last time I looked into dscanner, it has a separate pass for every check. Is that correct?
A separate what?
A separate visitor.
Yeah.
For every pass. One thing that I experimented with detecting unused variables a couple of years ago in DMD. And I came to the conclusion that it would be very nice to have some kind of high-level API to the visitor where you can feed inside the visitor a set of transformers or checkers on the AST, so you don't need to traverse the AST over and over again, because that would give better memory locality. The problem is that maybe some of these visitors modify the AST. But I think in a very long, if I were to design a compiler, I would have this in mind. So be able to pass a set of transformers or statistical collectors to a set of a parameter that's applied to each node in just one pass.
So I did kind of think about it, but at least in this scanner, I don't think we mutate the AST in any way. But in order to let's look at the extreme example where we move all 50 checks in a single visitor. It's so much state and so many things that you actually have to care about, and you're going to have to visit pretty much the whole AST in order to cover all the checks. And this would take out the freedom for the user to choose what checks to run. So if you only want to run 2 checks, you're still going to have to visit the whole AST. So I'm not sure whether or not that's a good idea for the user. And regarding the state, like, there's so much state that you have to keep track of. I wouldn't say it's impossible, but the code would be very ugly.
I was just wondering if it would make sense to add this to the list of projects that get checked in CI for DMD so it wouldn't break.
Yeah, we talked to Razvan and we think it would be a great idea, but once again, it's the compiler developer against the library user. Do you want to include any other projects that come up, or
Well, we'll see. I don't think there's going to be that many projects using DMD as a library. I'm planning to write one myself, but yeah, I think it makes sense. I mean, we could maybe do some log-sack changes in the compiler, and then this, so that we can transition things.
yeah, I think it would be a great idea.
So my question is why DMD as a library code is not being shared with the compiler right now? Because this would make things way simpler and also always up to date, and even every benefit the DMD as a library has, the decompiler ought to have to.
So is your question, why is DMD as a library not sharing the code with the decompiler?
Yes.
Well, they do. They are the same thing.
But you said you right now has to rebase every now and then, and I was thinking if that's not just a build configuration that could be applied to the upstream code.
When I talked about rebasing, I was talking about the changes that were going on in the DScanner, the official DScanner repository. So changes that are related only to DScanner. DMD as a library is another issue. It only receives updates. That's it.
Yes.
But it's the same exact code with the decompiler.
Okay, thank you.
All right, looks like you're done. Thank you.
Thank you.